Yeah. So basically subtractive manufacturing with the Fusion 360 and the ShopBot. So since we're not in our physical makerspace right now, we'll kind of just be going over the process of setting up a model to be cut, and then Summit happens to have a CNC machine at home, so he can show you some videos of a CNC machine working. Cool. So, all right. So I'm just going to give a quick introduction of the Startup Center real quick. So basically, what we are is we're a makerspace on campus, and also a resource for people interested in startups and entrepreneurship. Our mission is helping all UC Davis students start their ventures. If those of you who've been here before, you guys probably heard the spiel like a million times. So basically we provide resources for students at any stage of the entrepreneurial process. So whether you have no idea what entrepreneurship is, no idea what startups are, but you're kind of interested, you kind of want to learn what they are, to people who like want to be an entrepreneur and they have an idea for a business already and they just need a little bit of help getting it off the ground. We have resources for all that. So some of the things we offer is we offer classes on entrepreneurship. We have Intro to Entrepreneurship, which is kind of like a more theory-based class, kind of more of a lecture style class that teaches you about the concepts of entrepreneurship. And then we have Launching for Business, which is exactly like the title. It's you're launching your own business. So you'll be getting into teams in the class and kind of workshopping throughout the entire quarter. And by the end of it, you should have a business that's ready for launch. Hacking for Defense is basically the same thing as launching a business, except it's sponsored by the U.S. Department of Defense. So they give us kind of their own problems that they're trying to solve. So rather than coming up with your own problem statement, you'll be kind of helping solve those kinds of problems, so like energy type problems. And then also we have, so when we get a chance to actually go back to our physical space again, we have a makerspace, and with a lot of prototyping tools such as 3D printing, laser cutting, CNC routing, Arduino microcontrollers, as well as a virtual reality lab. So basically, if you have some sort of personal project you want to work on, or if the startup that you're trying to launch has like a physical prototype, our makerspace can help you with that. And also we have workshops that will teach you how to use everything in our makerspace, such as this one right now, as well as other prototypes, such or other workshops that teaches you some more like essential skills like group leadership and and resume building and stuff like that. And there's also VR workshops as well from our VR lab. And besides that, there's also a lot of startup resources that we offer, a lot of discussion type events, such as Pitches on Popcorn and our mentor visits. And those just kind of serve to help educate people who are interested in entrepreneurship and startups, but would like to learn more. So there's a lot of ways for you to get involved. And if you're set on trying to launch a business or you want to try launching a business, we have our Plasma Accelerator program, which is every year. It's a 10-week program. No, it's a 12-week program, and we accept 10 teams where you get some seed funding, you get mentorship, and you basically work on just refining your business, refining your product, your startup. And at the end of the program, you basically pitch your company, and you get a chance to kind of win some more money to help your business. So that's sort of everything that, well, not everything. It's a general idea of what we do at the Studio Startup Center. And we'll go into prototyping. So since this is part of the prototyping workshop series, we need to know what prototyping is. So prototyping is the process to get from an idea to a working product. And it is one part of the design thinking process, which is a process that is kind of apparent in almost any field where you need to kind of create something and create a working something. So whether that be, you know, in engineering or in I don't know, music production, art, anything like that. So there are 5 steps, technically 6, with the repeat step. So the first one is empathize. So first things first, you kind of need to know who is going to be using whatever it is you're making. So you need to understand, you know, if you're making a product, you need to know who your client is, who your customers are. If you're doing graphic design, you need to know who your audience is, stuff like that. And then the next step is define. You have to define a problem to solve. You need to define some sort of pain point, something where your product might be able to actually make better, something that your product can solve. And then ideate is when, you know, you actually come up with the product, come up with what it is that you're making, come up with all the ideas for your solutions to said problem. So once you have a couple of ideas, then is the step that we're kind of focusing on is prototyping. And the prototyping step is just basically taking your ideas and trying to make it a reality. So it's kind of trying to see if your ideas, if your solutions are actually feasible, if they actually solve your problem, and kind of refining that until you get a product that is actually solves the problem as well as you want it to. And, you know, the next 3 steps are kind of are pretty much interlocked together. So a big part of prototyping is testing. So you have to make your prototype, test it to see if it works, to see if it behaves like you want it to, or if there's some other problems that you need to solve, and then you repeat. And a key point is this isn't a linear process. You don't just go through these 5 steps and then, you know, you're done. You have to kind of go back, see what's wrong, and then maybe you might have to ideate some new ideas. You might have to redefine your problem if, you know, your problem is ill-defined, or, you know, you might have to rethink who your customer is, stuff like that. So you have to kind of go back and think of go back through every step of this process until you get a product that's actually satisfactory.
So CAM stands for computer-aided manufacturing, and that's basically just means using computers to control your machine so you can create a part. And that's basically any type of machine we have at the Startup Center. 3D printers, the CNC, the laser cutter, they're all CAM. And for this workshop, we'll show you how to use we'll talk about the ShopBot, but I'll show you a different CNC in the video, but they all run the same. So the ShopBot is the CNC router that we have at the Startup Center. It has the spindle that rotates an end mill or a cutting tool to create your product. And this is a subtractive manufacturing process. And that means you start with a large piece of stock and you cut away from it until you have what you want, as opposed to additive manufacturing, which is like 3D printing, where you start with nothing, you put down material until you have your final part. So the ShopBot works by following a list of commands to move the cutting head to cut your part. This list of commands is given in the format called G-code, and it's basically a list of XYZ coordinates that the tool can move in, with other commands to control like the speed and how fast the spindle is rotating. For the ShopBot, to know how to cut a part, we have to generate the G-code first of our cutting operation. And so this is how a router works. It's kind of different from a drill bit. They may look similar, but the difference is a drill bit is only meant to cut straight down, whereas a router has these kind of flared edges where you can cut in the horizontal direction. And climb milling is where you're cutting and taking bites out in the same direction that your router is spinning in. And then conventional milling is just going the other way. These aren't really things you need to know at the beginning. They're just more advanced things, so you have an idea of what these words mean when they come up later.
With machining, there's, as you can see, there's a couple different types. So the simplest one is 2D. So it's a 2D design it's a flat design with absolutely no depth. So you're cutting to one certain depth, and that's the entire design. So as you can see here in this example, it's the 2D. Basically, 2D machining is anything where the design can be drawn on like Microsoft Paint or something. 3D machining is kind of moving vertically, kind of having variation in the vertical direction as well as horizontally. So it means you can have kind of like variations of depth. You can have kind of like curves, as you can see in this 3D example. You have this kind of like curved text with these like stipples in the background. And so that's 3D machining. And then there's one slightly in the middle. So, and that's 2.5D. So with 2.5D, there are kind of multiple shapes, but at different set depths. So it's not smooth like the 3D one is, but you can get some variation in depth. So you can see here, there's V carving, which you can see there's kind of, so this is cut using a kind of like a V-shaped cutting tool. And that's what allows you to get this sort of like triangle cut, but it's still cut in one depth. And then afterwards, there's another shape in a different depth here. So actually, no, I think that's actually just another bit. But basically with 2.5D, you can have slightly different shapes at slightly different depths. So that's usually like 2 or 3 cuts, or 2 or 3 different depths, rather than like a full continuous range like 3D does. All right, so here you can see kind of the different parts of our CNC mill. So this is the ShopBot, which is again the one we have at the Student Startup Center. That it won't be the one we're showing today, but all the main parts are going to be there. So first we have the spindle, which is the motor that kind of holds and spins the cutting tool for it to cut. So that's going to be right here somewhere. And then the cutting tool is the actual bit. So that's the actual milling bit, like we saw before. That's what actually cuts into the material. The collet is what attaches the cutting tool to the spindle. And that's just sort of like this twist. If you've ever used a drill before, it's basically like the drill chuck. And one thing you have to remember whenever you're using a CNC machine is knowing what the different axes are on the machine and where your machine will home, or basically where 0, 0, and 0 is on your machine. So in the case of the ShopBot, the machine actually homes on this corner. Actually, no, we can actually set where the home is for the ShopBot. But the X, Y, and Z directions are set in this orientation. So you don't want to accidentally set Y going up, for example, and have, and then go to cut your part and have it kind of run into the floor. And then last, you have your stock, and that's the raw material that you'll be cutting, and that's the raw material that's going to end up becoming your final product. So obviously, when you're dealing with a machine that spins things to like 14,000 RPM, there's going to be some safety concerns. So of course, it's going to be really loud, and there's going to be things flying in your face. So make sure that when you're using it, you have to wear ear and eye protection. Don't reach into the machine. That should be obvious. There's a giant spinning cutting tool in there. So when something's wrong, you have to always be ready to stop the machine as fast as possible. And usually these machines will have multiple options to stop your machine. So usually there's a sort of a soft stop which is on the computer that's controlling the machine. And that just kind of stops the current instruction. So it stops the current movement. It's kind of more like a pause. So it can stop it, and you can kind of check what's going on. And then if there's nothing wrong, you can kind of let it keep going. So those are for things where it's like you think something might be wrong, but you're not sure, and it's not really an emergency, but you want to stop and check. If something is obviously wrong and it's becoming dangerous, then you need to go for the hard stop, which is like the emergency switch on the machine, and that's going to just completely cut off the power. You'll lose all your progress. You'll have to restart your part, but if the situation calls for it, that's the best option. And yeah, so we'll go over that a little bit more later.
So quick intro to Fusion 360, which is the software we use when we design and use the CNC. It's a CAD software that includes the CAM capabilities, which means that you can use it to model and also generate the G code for your part. And it's free for you. So if you want to try it at home, you can download it and practice CAD. And then from there, you can see if you want to learn what the different tool pathing is in CAM. We're only going to go over it briefly. So CAM is, you go under this top tab, it'll say design. You'll click on it and go to the manufacturing tab. So you have to have a model already imported into that Fusion 360 document. And you can either import the model from an STL, or you can model up your own in Fusion. If you model up your own, you have more options when it comes to doing the tool pathing. But if you bring in the STL, then you have to kind of be restricted to the limited, I guess, knowledge that Fusion has of that part. So the first thing you're going to want to do is create your setup. And basically this defines where the origin point is in the WCS. You can define the type of operation, and for this is milling. Now in Fusion 360, you can do 3D printing in the manufacturing tab, so just make sure you have the proper one selected if you do this. And then you can select which model you're cutting out if you have more than one model in that document. And for the setup, when you do the origin point, you want to keep in mind again how the X, Y, and Z axes of your CNC are. So here you can see in this picture, we have Z going up, Y in this, like into the machine, and then X going left and right. And that's the way we made sure to have it here. Z going up, Y going into the machine, and X going left and right. And this just lets you know that if you're looking at the stock from this angle, this is how it's going to come out on the CNC, instead of like putting the homing point on the bottom and then trying to account for that. And you always want to make sure your home point is selected on the top of your stock, because some machines after they finish their run of Toolpath, they will return back to home. And if your homing point is, let's say, on the bottom in the middle, it'll run through your part and then go back to that point. And then you can set, and the next tab, you can set up your stock, which just defines how big the part that you're cutting out of is. And you can either set it to be a fixed size or like relative just to the model you have and just say, oh, it's 1 millimeter bigger on either side than this model, and then have it cut out of that. Then once you have that defined, your setup is done, you can click OK, and you can go into creating toolpaths. So there's a few different types of toolpaths you can pick from. Like, there are so many toolpaths you can pick from. It seems overwhelming, but a general rule is to have just 2 sets of operations at minimum. Versus roughing, so you can remove a lot of material quickly enough to get like a approximate shape, and then a finishing operation to go in and get more precise detail. So you can see in this picture, this, like, I remember, I think they called this thing Kevin in the video. They did a roughing operation, which left these like this stair-stepping pattern, and then they're going through with a finishing operation to smooth it out and create the smooth surface. Some common operations include adaptive clearing in both 2 and 3D, which will rough the material out around your part and just give you a quick approximate shape. Then you have facing, which is good to take a thick piece of stock and cut it down to the thickness that you want. Or if you have a warped piece of wood, you can like use the facing to create a flat surface for you to start with. Pockets trace the inside contour of a part. So if you have like some part with a cutout in it, you can use pocketing to clear out the inside. And a contour cut is the same thing, except it traces the outside. Engrave is that thing with the V-shaped bit we saw earlier on the 2.5D and 3D tab or slide that creates things like that. So you're going to want to go when you start up your toolpath, you're going to want to go through these 5 settings where you determine the tool and the speeds that it should cut at, the geometry of where the tool is going to cut, the heights, like the top and bottom clearance heights to prevent the model from the toolpath from crashing into your stock, and the passes of how many passes you want it to take, and we'll go into depth with these. So before you select your tool, you're gonna have to import a tool library for your cutting tools, or just pull up a set of calipers and measure your tool so you have all of the sizes and stuff properly set. That way Fusion knows that if your tool is only like a 1/2 inch in cutting depth, it won't let you cut a 3/4 inch slot through your piece. And generally, if you buy a bit, it comes with all of the measurements you need to know on the box and like what speeds and stuff you should use it at. Geometry lets you define which features you want to cut, and for most, you can choose contours and like the outlines and faces to cut. The stock contours selection is also useful to tell Fusion 360 like not machine the entire stock away and just kind of keep it within like however much you define of the actual part. Heights let you set the different ways the tool. So the tool will start at 0, which is the top of the stock. So this allows you to define. This allows you to define how high back up it'll come after it cuts. So let's say you want to make your thing cut your part cut faster. You can have it retract only like 1 millimeter above your stock surface, but you want to make sure that's not too low so it doesn't, so there are no issues with the crashing. And just before we move on to the video, one quick thing to keep in mind is when you're cutting with a router, the good rule of thumb for like pass depth of how deep you cut every time you go through a pass is a maximum of 1/2 of the tool diameter. So if you have a 1/4 inch bit, you want to only cut with an 1/8 inch of depth per pass. But if you want to go more fine, you can always use smaller bits. Dear God, hold on. Sorry. Yeah, and now we'll just move on to the video I have. So you can see here I have the spindle is a little different in this machine. It still has the same XYZ axis. So X is running this way, Y is going into the machine, and then Z is the spindle moving up and down. And when you start with your part, you want to make sure your workpiece is secure. So I have 4 clamps here, and then I have 1 more clamp on that side and 1 clamp on that back, just to make sure nothing moves. Since you are spinning this router and this end mill at like 12,000 RPM and then shoving it into a piece of wood that's staying stationary, there's a lot of cutting forces involved. So you can see it's cutting. This is an 1/8 inch end mill, so my cutting depth is 1/16 of an inch, and that's a little bit on the aggressive side, just because I knew that this wood would cut pretty easily. You'd want to stay a little bit less than a half of the less than half of the depth. And this operation is an adaptive clear, so it just cuts out the rough shape, and I used that, and then following that I used a pocket to cut out this little heart since I wanted to clear it all out. Yeah, that's the end of that video. Jovan, do you want to add anything?
Nope. Yeah, that pretty much covers it. And yeah, anyone have any questions?